Good morning, students. In ninth standard, yesterday we have learned about isosceles triangle theorem. Then, in this period, we learned about corners of isosceles triangle theorem. We know the isosceles theorem. The statement of the theorem is: if two sides of a triangle are congruent, then the angle opposite to them are congruent. If any two sides of a triangle are congruent, then the angle opposite to them are congruent. We have seen in we have learned about in last period. Then converse of isosceles triangle is converse of isosceles triangle. Converse of isosceles triangle here. Isosceles triangle theorem. Then statement of the theorem is: if two angles of a triangle are congruent then sides opposite to angles sides opposite to angles sides opposite to angles are congruent. The statement of the theorem is: if two angles of a triangle are congruent, then the opposite sides to them are congruent. Then we have given that. Firstly, write given. If two angles of a triangle, we draw one triangle. Triangle PQR is isosceles triangle. Angle Q, angle R between any two angles. Angle Q and angle R between any two angles is given that in triangle PQR. In triangle PQR, we have given that two angles of a triangle are congruent. That is, angle PQR congruent to angle PRQ. Angle PRQ we have given that. We have to prove that. Sides opposite to angles. That is, opposite sides of angle PQR is angle Q. Side opposite to the angle Q is side PR, and side opposite to angle R is side PQ. Then side opposite to the angles are congruent. That is, side PQ. We have to prove that side PQ is congruent to side PR. We have to prove that side PQ is congruent to side PR. Then we have to next step is construction. We have construction. Draw the bisector. Of angle P intersecting the side QR intersecting side QR at point M. At point we have draw one construction. Construction is draw the bisector of angle P. Draw one bisector of angle P. It intersect at point at side QR at point M. At point M. Then next we have to see proof of the theorem. We have to prove that side PQ is congruent to side PI. Then proof is firstly we have one construction, that is draw bisector P. Draw bisector of angle P, and this bisector intersect to side QR at point M. Then two triangles are formed, that is angle PQM and angle PRM. In triangle, two triangles are formed in triangles PQM and triangle PRM. In triangle PQM and triangle PRM, angle PQM is congruent to angle PRM. We have given in the statement. This is given. Then next step is angle QPM. Angle QPM is congruent to angle RPM. It's congruent to RPM. We have given in the construction. Next one is, third one is segment PM is congruent to segment PM. That is common side of two triangles. The reason is common side. The reason is common side. Then therefore triangle PQM is congruent to triangle PRM, by which test two angles and one side is common or congruent. Then by angle side angle test, triangle PQM is congruent to triangle PRM. Then in this way, if two triangles and one side is congruent, then remaining two sides are congruent. That is, we write as from angle side angle test, we write as a, therefore segment PQ is congruent to segment PR. Segment PQ is by side angle test, segment PQ is congruent to segment PR. This is proof of the converse of isosceles triangle theorem. Then next we have given corollary. If three angles of a triangle are congruent, then its three sides also are congruent. Then its three sides are also congruent. This is one corollary. Then our next point is property of 30 degree, 60 degree and 90 degree triangle. Next point is property of (30°, 60°, and 90° triangle. This is our next point. We have given two activities. First activity is every student in the group should draw a right angle triangle. Every student in the group should draw a right angled triangle. One of the angles measuring 30°. One of the angles in the triangle are 30°. The choice of lengths of sides should be their own. The choice of lengths of sides should be their own. Your own choice length of sides. Then each one should measure the length of hypotenuse and the length of side opposite to 30° angle. One of the students in the group fill in the following table. Table is triangle number, length of the side opposite to 30°, length of the hypotenuse. We have draw one table, triangle number. Second row is length of the side, length of the side opposite to 30° angle. And last row is length of the hypotenuse. Length of hypotenuse. Length of the hypotenuse. Then triangle number 1, 2, 3, 4. Then did you notice any property of triangle, of sides of a right angle triangle, which one of the angle is measuring 30°? We have given activity. Activity first is every student in the group should draw one right angle triangle. Every student in the group should draw one right angle triangle. One right angle triangle, A, B, C, D, right angle triangle. Then one of the angles measuring 30°. The choice of lengths of sides should be their own. Each one should measure length of hypotenuse and the length of side opposite to 30. Each of measure length of hypotenuse and angle opposite to and side opposite, length of side opposite to 30°, that is AB. Then in this way draw 4 triangles and find the length of side opposite to 30° and length of hypotenuse. This is our first activity. Second activity is the measures of angles of a set square in your compass box are 30°, 60° and 90°. Verify the property of sides of the set square. Activity second is the measures of angles of a set square in your compass box are 30°, 60° and 90°. Verify the property of sides of the set square. Let us prove an important property revealed from these activities. We have to in the basis of the two activities, Let us prove important properties revealed from these activities. Then theorem is if the acute angles of a right angle triangle have measures 30 degree, 60 degree, and then the length of the side opposite to 30 degree angle is half of the length of hypotenuse. This is theorem of 30 degree, 60 degree, and 90 degree. We have to prove this theorem. Firstly, we understood the statement of the theorem. Statement of the theorem is if the acute angles of a right angle rectangle have measures 30 degree and 60 degree. Then length of side opposite to 30 degree angle is half the length of hypotenuse. We have given theorem of 30 degree, 60 degree, 60 and 90 degree. We have given if the acute angles of a right angle triangle have measures 30 degree, 60 degree and 90 degree, then length of side opposite to 30 degree angle is half of the length of hypotenuse. This is our theorem. Then step by step we will see proof of the theorem in the next period. Step by step we will see the proof of the theorem in next period. Okay, thank you.